Hello and welcome back to another episode of Extends by Strengthex project. Today we're being joined by my colleague Dr. Mitar Simic. Hi Mitar.
Hi, Adrian.
How are you feeling?
Very good, and thank you for this invitation and opportunity to talk.
So, tell me what's your background story? What's your origin?
Yeah, okay, for that we need to go 35 years ago when I was born in Ljubovija, which is a place in the western part of Serbia. But actually, most of my life I spent in Bosnia, in town Bratunac, which I usually acknowledge as my hometown because, as I said, majority of my activities, life, everything was spent there. And then in 2006, I started my bachelor studies in electrical engineering at the Faculty of East Sarajevo.
After that,
I finished
how
it.
did you come here?
Yeah, I finished that in 2010, then enrolled to the master studies, and then in the summer 2012, actually, I think that was the like a turning point that actually led to this engagement. It was the summer of 2012 when my colleagues who worked as teaching assistants at the faculty at the University of East Sarajevo, they were talking about, okay, we want to start PhD studies. For me, it was like, okay, we, during our bachelor and master studies, so many, still open questions that they said, yeah, this is something that you can explore more, but that is not covered with our program. And I was always thinking that at that point, that PhD studies will cover all that, holes that we now have.
Yeah, well,
After the studies.
wishful thinking.
Yeah, but actually then and then that was okay. I want that, it's you still, that is a great opportunity to learn those things. And that was actually when I was thinking about enrolling at some PhD studies, and then I came to FP7 project here at the University of Novi Sad, but I was situated and worked in a company in Subotica.
So for everyone that might not know, that's another city in Serbia. It's close to the border with Hungary. So
Exactly.
you were not really in Novi Sad throughout your studies.
No, yeah, actually,
previously.
I was just coming here for the exams, and that lasted about 2 years. Yeah.
That was a logistical nightmare. Well, good luck. I don't
Yeah.
know. But at least in the end, it was successful. So, yeah.
Yeah. Now, thinking from this perspective, yeah, of course, it was a lot of some tough moments during the winter season here or whatever, when you need to, as you said, to perform the logistic, to be here on time for the specific activity. But yeah. And then I actually realized that with the PhD studies, we have one very strong specialization, very narrow field, very narrow topic. And yeah, but still I enjoyed it. It's not something that I was thinking as a bachelor student without any discussion with someone with more experience, because in our group all friends usually stopped on the bachelor or master studies. It was not that often. Now I think that is even more frequent. You can know someone who is in the PhD studies.
Yeah, and also I believe that is also some kind of field-dependent decision if you will go for a PhD or not, because fields like electronics engineering, I think they're perceived as a bit more practical-oriented, industry-oriented. So maybe most of the people will decide against the PhD in the field,
Yeah,
rather than,
exactly.
let's say, some kind of applied science.
Exactly. I also had an interesting lecture at one of our classes at the master's studies, when one of my professors said that even master studies, usually people take only if they are thinking about going for a PhD studies later in our field. That for majority of the people, bachelor studies are good enough to start to work, and yeah, maybe that is definitely, yeah, field dependent.
So how about you entering this field of electronics? What was your motivation to do that?
I think that it was a combination of the several factors actually that reduce the, let's say, the possibilities. I cannot say that I didn't enjoy, but I also would say that some things were just the logical extension of the previous activities. I think that a good starting point can be marked my discussion with my father about the one of our neighbors who was enrolled in this high school for electrical studies. And one of his comments actually was, yeah, that is a very good profession, and of course it's up to you, but it's something that it's one of my recommendation. He was not in that field, actually he was for the mechanical engineering and he had no knowledge about that, but his perception was that that is something that will be also good for the future. And another thing I think that was very important is that high school was in Bratunac, in our hometown.
So you didn't really have to move.
Yeah, my older sister was traveling every day, was commuting to another city for her medical school and different experiences. And she was 5 years older. She was in France, so I was able to hear, about the bus is cancelled, the snow is big, I was late on class and those things. And I think that, and then I actually with good, and the third reason was that one of the professors in that high school was my basketball coach. At that time I was practicing basketball, and that is, I think, the good combination of the factors that actually put that. And after that, when that was the background, then the choice of the faculty was almost there is no debate in my head what is the next step. Let's go with that faculty, and that was the story.
So bringing back you to today, let's say, or to a few years ago, what would you say that your specialization is in terms of what you're doing right now? Because obviously electronics is a massive field, so...
Yes. And actually, I had opportunity to see that there is a lot of directions that different research groups cover. And one of the things that again were based on the experience, available equipment, and after that some personal interest was developed, is is electronics. That is, let's say, on the level of the solid state components. We are not talking about the microelectronics or the nanoelectronics that is now available. We are talking about the integration of the different integrated circuits with some purpose, which for me the main challenge is the readout of the sensing data, to do the proper sensing in terms of how to keep the important information, how to do not affect the performance and the behavior of the sensing element with connection of our instrument. So that still is demanding, still open question, and I really enjoy doing that.
So practically speaking, for someone that might not be in the field, you would say that, okay, in an oversimplified way, basically you are working with the electronics that we are used to finding in our everyday devices, some kind of, let's say, monitors, computers, whatever, only in smaller sizes and with something that has to do with sensing something, like, for example, the speed in our car or something like this, right?
Yes, exactly. Those layers beyond that presentation of data.
So how would a typical working day be for you in this project?
Working day starts a little bit before coming to the faculty, because I would not be able to start to work without that morning coffee. Let's say that is something that
That's interesting,
that I
of
really
course.
need, and that I usually say that first cup of coffee is something that put me in the center and enable further operations. So if that is missing, sometimes, of course, I'm not able, but to do it if some special circumstances are there. But I would say that that is the actual start. It's usually 6:30 in the morning, and usually around 2 hours later, for example, the start of activities at the office will be. Sometimes we have meetings, sometimes I need just to check if some email with some very specific request arrive that I need to do immediately that morning, or to plan for that later in the day, or I can reserve that time for my activities related to the research. I work in the morning. Someone maybe likes to work in the night when it's more quiet, but actually for me this morning is the period of time when I'm the most focused on the work.
And in terms of, let's say, your research, obviously, research in academia is not something that you go to the office one day, you have a task, you finish the task, everything magically works, and the next day you're like, oh, I have this great product, let's start putting it to the market. Obviously not, but in terms of, let's say, your research, how to say, a specific research task that might span few days, few weeks, etc. What's your approach to it? How would you, let's say, start it from, let's say, the inception to measuring it, or having an actual device?
Yeah. Usually, the understanding of the process that we want to now to be covered with our electronics also requires time that we or I need to understand. Okay, what the conditions with my electronics I need to meet, and also to see what is already available in the scientific literature, what people were doing. Is it something that we can use that is already available, or we need to somehow improve that design or specific realization in terms of, let's say, the dimensions or the power requirements, something that is optimized for our application. And I would like to say that maybe one of the good things that happened to me, that before academia, I worked around 5 years in the industry, where I actually realized that we need to always have something that it is fully reliable for the application, and sometimes to have something unique that will make the difference between our device and what is already there. We need to have something which is enhancement to the current state of the art. Sometimes it's not easy, sometimes
Yeah.
we failed in that, but it's something that is the joy of our work, if I can say, that we are still in the battle. We usually can compare with others, we can compare with our previous designs, how it can be better,
True, but I think there is a big, let's say, rift between academia and industry in this field, because generally when you're working in industry, aside from the fact that you have to be super secretive about what you're doing, generally you're trying to do something that has a valid value point from its inception. So it might be something that nobody has done before, like a new device, or it might have been something that's totally different to something that has already existed. Like, for example, conventional batteries versus these now solid batteries that are super high capacity, etc. But in academia, I think the lines are a bit more blurred. It's like you can read about all of the how achievements that other teams have done, because most of the publications that we're doing are open access, readily available to everyone. You can even replicate their methods. I think that's also one of the things that when you're writing a scientific paper, for whoever might not know, it's one of the requirements that when I need to present something that is replicable, so
of course.
with enough detail that others can actually reproduce my work. So when you're tackling some, let's say, research task here in the academic environment, what is your drive? Like, do you start by going through whatever everybody else has done, try to find a small gap, and do something novel there? Do you try maybe to see what others have done and do it in a different way? Or you just think completely outside of the box? Like, what do you normally do?
Yeah, I can say that that I do not have some unique approach that I always apply to solve these tasks. Sometimes it's sometimes there are very inspiring papers that you can learn a lot from them, and then, for example, in conclusions they can point out some open questions that can be done in the future. They planned it to do it, but sometimes they just change the area of interest to something else. And that can be a good opportunity to find that gap that can improve something that is already there. Then important thing is, of course, am I able to do it?
Yeah, true.
Do I know it? Do I have the equipment that we have here? Usually that there is a compromise between those aspects that sometimes, yeah, there are very good approaches, but you simply, yeah, you lack of knowledge or the people that can help you to do it. Yeah.
And also in academia, to avoid any misconceptions. For example, in the industry, if I have a brand new device of any kind, let's say a brand new supercar or whatever, I protect it with 50, 60 million different patents so that people will not replicate it. Because, for example, somebody else from another country might be able to do it for better and for cheaper. Normally, in the industry world, that's copyright infringement. So it has some legal implications. In academia, it's actually what we're after. Because somebody, let's say, from a university, with, as you said, many means, financial, equipment, team-wise, etc., might do something that achieves a great result, and somebody actually from, let's say, not as privileged area, not as known university, not as known team, might actually be in a position to have an idea to reform this into something that is actually doing the work for better, for faster, for cheaper, etc. And just to avoid the misconceptions there, this is actually sought after in academia. It's not, let's say, how to say, copying or whatever.
Yeah, exactly.
So, okay, interesting, but let's say with the means that you have and with the team that you have and with the instruments that you have, your set environment right now. I assume you're working on, let's say, a few tasks simultaneously, other are progressed more, other are progressed less, etc. What are you trying to, let's say, achieve? Are you planning, for example, to create a sensor or a system or a device that is ready for the market? Are you trying to create something that's, let's say, the goal is to prove that it works well enough? How are you approaching this normally?
Usually, my main goal is to make something that can operate in, let's say, standalone configuration that is not dependent on the settings of the user, which can be, of course, then affected by the knowledge of the user of the specific topic, and then it can make the impact on the results. So basically, if we are talking about the measurement time or the measurement resolution or all other aspects or configuration of the setup, I like to define that they are, let's say, hard coded under quotations, that there are no opportunity that someone else can perform it in wrong way. In terms of the wrong way, I say that it doesn't cover all the aspects they should be done. As I said, if you are talking about the measurement time, then the sampling time or the sampling frequency will be defined by me. That is,
Yeah, but don't you have to like make multiple trials to see which are the best configurations so that you can, let's say, hard code them, aka put them in the software for the user to not be able to play with?
yes. Usually I do that. That is the task that, and I like to do that also to learn for about the process. That is it. If you are talking about the temperature regulation, I will probably spend a few days just to see if my regulation algorithm will do it. Later, of course, always ready to correct it, but somehow I want to see how it actually operates, or if before giving to someone else, just to know, yeah, okay, this is what we can expect. Is it reliable, or there are some things that we need to change?
And during this phase of the process, because again, opposite, let's say, the industry where your manager or your, let's say, director will give you set requirements that your work has to achieve, be it, let's say, set parameter values, set thresholds, set costs, set whatever, but set of parameters. Here you don't really have that. I mean, you're still exploring it and going around it and whatever, and basically defining everything yourself. So do you have any clues or any steps as to how you would say, okay, now I'm happy with what I've done. I don't need to try another parameter, or I don't need to try, let's say, splitting this parameter into 10 sub pieces to check 10 times more. So, like, what's the approach there?
Yeah, that is again related to one of the tasks that I was doing, let's say, 6-7 years ago, when I was trying to let's perform the parameter estimation with the complex nonlinear least squares. And there was the procedure includes a lot of configuration steps that I had to do. Okay, I was able to get some results, but then when I was trying something else, then the results were not good. So I realized that I need to, that was like termination tolerance, or the step of the estimations. You could see that you really can impact the results. The method itself is okay, but
Yeah.
your inputs can make it to have results better or worse. And that is what I want actually to eliminate in my work, that I usually want to test in some, let's say, range of the input values, or let's say 10, 100 sets of the repetitions. And that, of course, it's never ending. At some moment you need to decide, yeah, okay, this is now I have some statistics that I can say, yeah, okay, it is in reliability, and that is usually when I stop. Of course, if I realize that there is a big disadvantage or some issue with the work, I need to correct that and then to do it again.
Yeah, okay, but like also to loop our listeners into that so that they will be, right, let's say, in a better position to understand what we're doing. Recently, within the project, we published some work. Published means an academic paper, uh, based on which we created some textile threads, like the threads that we normally use to mend our clothes. Only these threads were coated with silver, and we took these threads, we created a geometry, let's say, to put it simply, on a mask, like the mask that we use for COVID or the general protective masks. And we interfaced that with some electronics that Meter did, and basically we were able to detect, let's say, in a way, how the person that wears this configuration breathes. If they breathe fast, if they breathe slow, if they breathe, let's say, in a big volume or in a lesser volume, etc. So normally when you submit this as a paper, the process is that you have a review, and when the review is done, some people of the field will come back to you and say, well, I like what you did, but you should also include this, or you should also take this into consideration, etc. Normally that's what you do to publish a paper. But again, this is not a standard specification. I don't need to create a product that fits these needs for this user, for this price point, etc. It's academia, it's research, so it's kind of like a free cloud of things. In our work, for example, we did this on masks that are generally considered single use. We could have done this, transferred this on masks that are not single use, that are made from cloth, let's say, that we can wash and that we can use again. Okay, not infinite number of times, of course, but a few times at least. If we had done that, obviously, at least in my mind, because this research was joined, I would assume that we also needed to run, let's say, a washability test, which is something that we didn't need to run in the first case. So the general idea is, do you have something on the back of your head that tells you what to do, what not to do, what is worth doing, and what is not worth doing? That is, I mean, it's a question that obviously it doesn't have a right or wrong answer. It's methodical, but I'd like to hear a bit how you approach that.
Yeah, it's something that we usually discuss among us when we are preparing the paper or the study itself. Sometimes such studies are needed. If we develop a device that can be washable, then of course washability study, for example, as example, should be included. Sometimes that can open some, let's say, new questions that should be
Exactly.
that should be answered because they are now there. And it's something that we usually agree on that what will be, let's say, what are the steps that we want to include in the specific study. uh,
Yeah, I get it.
yeah, something like that. It's always the in my mind is always that we want to put if we are doing something, that we put a specific hypothesis in front of that we want to prove or disprove, but we want to answer on something, and that is usually the let's say the backbone of our papers, that we want to discuss and make things around that.
Yeah, because I think like at the end of the day, this question is a bit of not never ending, but actually it's a loop. Because let's say I have device named A or sensor named A. I have to run 3 tests, whatever, and get some results. When I get these results, I realize that they're not enough. But if I do some statistical manipulation of these results, I can actually get an indication of how the device operates, what I should probably, let's say, change, and go back to square one, remake the device, run these tests again in a relatively concise period of time. However, I can just opt of, instead of 3 measurements, make 13 measurements, 30 measurements. And instead of the statistical manipulation, get the indication from these 30 measurements. But that would have probably taken me 10 times more time to do it. So that's why I always like, to get perspectives on this question, on this approach, because some people will say, well, I don't mind spending infinite amount of time on this one thing as long as I make it perfect. And someone will be like, well, this way is smarter than, getting infinite amount of results. And some people will be like, yeah, but this is actually more concrete, is more proved. So again, it's a bit of,
Yeah,
mix and match situation. That's
yes.
why I'm asking, like, how do you approach it? Because for me, normally I would go, let's say, okay, concept simulation. If I have simulation, I do a set of tests. If they're relatively close, I will proceed. If they're not close, I will go back again, resimulate, recreate, etc. So
Yeah, that is, yeah, always a good approach is to have that solid base in the analytical terms or the simulation that actually can give you, okay, yeah, this could be a good direction. Of course, we are good as far as our models are, but those things I think that definitely should be included wherever we can.
as we are generally talking about the experimentation field, another trick question that I often, let's say, get asked or participate in conversations about is, are there bad results?
Yeah, that is, for example, the very good topic to discuss. I don't know if even I think that even sharing of, let's say, I don't know, is it, should we call it bad results or the negative results? I think it's always a good opportunity to share the experience of that. For example, if you later, if some other research group would like to do it in the very similar way, they got their idea, but actually it's very common that we have very similar ideas about the specific solution. Then I think it would be very good to read, yeah, okay, if you read their paper and the conditions that they applied, this is something what we can expect. I think that even negative results could be a good to read, but in that is in academia we usually focused on positive results, to have novelty, to have
No,
those
actually, I think that the
aspects.
focus is to not disprove a hypothesis.
Yeah, I
So
think
in that case, like you might, let's say, only put the how to say the results that are showcasing at least one part of your hypothesis that actually applies, versus let's say that okay, my hypothesis was this, I up to this point succeeded in basically verifying it to whatever extent. However, because of this condition or because of this effect of something, this is not what I expect to happen. So I
yeah,
think that the latter part is generally, out of the scope of a research when it gets published.
yeah,
But
exactly.
I think, at least personally for me, it's very encouraging that I see on various repositories. So repositories are basically places that you just dump your data, not officially, so not in the form of a paper or in the form of a review or something, but they are just out there. They're not just for you. And I think it's encouraging to see that more and more people are actually including all these, let's say, trials, because I don't want to call them bad results,
Yeah,
there. Because even that, at least for me, it's a process of, let's say, creating your device. Because if I get some data sets that do not really satisfy the purpose of what I built the device for, this is the indicator for me to go back and recreate my device.
exactly.
So in that sense, it's really not bad.
Yeah,
But
I wouldn't say
again, I
bad.
wouldn't put
Yeah,
it on the paper, maybe, or somebody else might not. So
yeah, but still we could learn from those results.
is it stressful sometimes?
Yeah, sometimes I think that it can be, it's just, mm, it's not because of, I don't know, me, you, or the team, a time arrangement, but sometimes the things simply, the deadlines are very close among those things that we uh, classify as important things to do and to make it on time. And then I think that time management is usually the critical aspect of the work, that you can say, yeah, now I feel very stressful or not. Of course, if you are doing a lot of things, if you invest a lot of time on the specific topic and the results are, as we said, not good as we want, that is also again stressful, because I can think, okay, what I can do now, I'm now stuck, what I invested a lot of time, what I can share, what I can say that is my contribution. So yeah, those things are sometimes very uncontrolled, but they are present. I would not say that it is not the constant. It's not something that we also cannot predict it, but yeah, from time to time, yes, of course.
And given the, how to say, the general liberty of your work, because obviously in academia, yes, you have a line of command, you have your supervisor, you have your researchers, like your team, your peers, etc. But generally, for let's say a big chunk of time, you are totally autonomous. Even when you are working in a team, you have a task, you have your results that you have to make in your own time, trial, let's say, as many things or as many parameters as you want, and at the end of the day go back to your team and say, okay, this is my part, it works like this, so your part also works like that, so how can we put it together, etc. So generally there is a lot of autonomy and a lot of, let's say, personal time management, etc. Would you say that potentially this can impact your or anyone's mental health?
Yeah, I would say yes. I would say yes, definitely. That as you said, a lot of time we can organize in in according to, let's say, our plans, our habits, whatever. But again, if that organizational time does not lead us where we want, then it can open a lot of, personal questions, that you can question yourself. Okay, what I can do better now. I had a lot of time to do it. I didn't do it. What is wrong? Am I capable to do this. I think that definitely, and usually the thing is that I think that one of the important aspects is that when we compare us with someone else, and
Yes.
we never know
That's a
we
loophole.
never know the complete story what is there. But
Yeah.
if you see, for example, some other research groups or the specific researcher, you can see a lot of things, but the good things are happening, and you can say, yeah, that group, they don't have any issues. But usually it's not that, it's
No,
always
everybody has issues. Yeah.
even in smaller communities or the bigger research groups, it is something that definitely can affect.
I think it also, without wanting to actually blame it, but I think it also has to do with the format in which we are either disseminating our results or are present in the dissemination of results of other groups. Because normally that is either a paper, which after having being peer reviewed, generally it's a lot of streamlining process involved until the time that I will actually read it. So it kind of looks perfect, but doesn't give me a time constraint of how much time they spent on actually bringing it to the stage. Or it can be a poster, which literally means something is printed. I have usually 5 minutes and I have to present it, where obviously to make the most of these 5 minutes I will omit, oh, but yeah, I tried this 10 times, or this took me 3 months, or whatever, or this material was super hard to put together. Or we're just going to networking events where you're like, oh, where are you from? This university or this company. What are you doing? Oh, this work. Okay, let's meet or let's talk. But until you actually talk and actually decide to commit to a partnership and say, well, I can do this, but like this is a constraint I cannot achieve, etc. Almost always we're just, having this flash session of, okay, these are my results, this is good, this is bad, this is what I did, etc. So something that might look very polished,
Yeah,
we
but
always
your
go
point,
into this, let's say, rabbit hole of, oh, but they did this, it's very nice, but how can we not, or whatever. And it stresses us, a lot.
yes,
But we never stop to think, yeah, but like, okay, they did it, but in how much time? With how many resources? With how many work hours, etc.?
yes.
Okay, interesting. Speaking about, let's say, the general field, have you come across any really bad practices in terms of experimenting in general? Or what would you personally consider a very bad practice that's like a no-go for you?
Definitely one of the things that I always have in my mind, that we need to have repeatability of the results. In the science, we like to say that exception does not make a rule, but the rule is broke with exceptions. So we need to have the wide coverage of the testing conditions. And I think that if we omit something that is important for the results, and we know that if we do that, that will disprove our hypothesis, at least should be noted that that was not done, give it a specific reason why was that included, and then that put, let's say, the boundaries that where we know that specific paper can be applied. I would say that is something that is against my, let's say, the personal rules, that those things are, even if we have less papers, lower production, it should be something that is repeatable, something that we really enjoy to put our names there. Because one of stories that I would like also to share was from my colleagues from the Norway, and when we were writing one paper, then he said, yeah, I think he was almost retired at that time, and he said, yeah, I think this is a good paper, and we need to think that this paper probably will live longer than we.
Oh, nice.
Yeah, so that is, okay, now we don't know what will be the future of this scientific production, that when always is online, how it will keep in the future in terms of the format, access. Those things are still, of course, something that we will see in the future, but we need to know, when it's published, then I think that we need to be happy and really proud of that.
Nice. You did me proud so far.
I
And
really
because I
enjoy.
really don't want to tire you more, we will play a game now. It's
Okay.
called Out with Five. I will
Okay.
ask you 5 different questions, but these different questions will be the same across all of our podcast guests.
Okay.
So, yeah, like, ready to start?
Is there a winner or is there a
No, there is
prize?
no winner. It's just,
So it's again there is no bad. So I can assume that there is no wrong and correct answer now.
of
Yeah.
course not.
Yeah, okay.
Also, they're not closed questions, so it's not like yes, no. It's like your personal output on some things that
Okay.
might be interesting for everyone to know so that they don't just know a name, but they also know a little bit of a character.
Okay. Let's see it.
Okay, so question number 1. What is the person, it can be dead or alive, that inspires you the most?
Okay. If I must select one, I would say that is Serbian scientist Mihailo Pupin. I would put him, let's say, a little bit in the front of the line with a lot of other names. But work of Mihailo Pupin as a person who came from the small village in Serbia, who was later established as a scientist and a professor in the United States, and his comments about the the need that even teaching stuff must be included in the experimental work, so that is not enough to know the basic things from the book and then to go and teach students about that. You also need to actually see how it works and to always have the balance between the theory and the experimental work.
Yeah, that's nice to say because generally sometimes there's the conception that okay, now I'm teaching you the basics. So this is your theory, these are your formulas, and okay, when you experiment, it's another story. Well, actually, it's the same story.
Yeah, there is, yeah.
Good. Question number 2.
Okay.
If you had the attention of the entire world for 5 minutes, what would you say?
In such opportunity, probably you would like to use the complete period of time that was given to you, but in general, I'm not, I would say that I would probably spend some time to find a person who would talk instead of me, because, for the better representation or those things. But definitely one of the things that I think is not the cliche, but we definitely would like to live in the world without wars, because I think that in peace, peace is the right conditions in which we can develop our relationships, our work, our society, and all. Because when it's war, everything is devoted to that. Everything is driven to not lose the war, but actually, as person said, it's always it's easy to end the war, but it's very hard to establish the peace even after that. So those things, as a person who grown up in area that in my childhood was covered with war activities, definitely I would ask for that. Of course, we also need to think that this planet, this is for us for a specific period of time, but also there is a life before us, there also will be after us. So I would like that we need to think about how to save and how to make it more good place for living also for the generations after us.
So generally, don't make work and don't make work to the next generations.
Yes, and don't waste if don't make a big waste if you don't need.
True. Interesting. Number 3. What can we expect from you next? Next can be whatever you define. 5 years, 50 years, up to you.
Let's say a few weeks ago, actually a few months ago, when was my birthday, I was thinking about what is next, what are the goals, and then I was thinking about digits when you're talking about your birthdays. Of course, I realized I'm 35, and then I was thinking, okay, would it be good to have to reach your journal publication number with the number of your with your age. So let's say I would hope that at the age of 36, or better to say at age of 37, I could reach the same number of the journal publications. But as we said, the good ones, that we are proud on it, and those that would I
But
say that is a goal.
but I can say you're quite on track to achieve that, at least with what this project is concerned.
Yeah, this I think that we are in good productive group. We are oriented to our results. So I really enjoy that, and I hope that together we will make that dream achieved.
Number 4. What is one final thought you want to leave our audience with?
I would say that we are in progress in, let's say, on different topics with our project. So I would definitely say follow us for more details and about our achievements. Listen to our new episodes of this podcast. Also follow us on our social medias. Website is there also, that because our, let's say, main goal is to do all those things not just because of us or reaching the specific number of the publications. Is something, our main goal is to make life better and easier for the general society. So hopefully we will accomplish that.
Yeah, that's true. We're trying to output research, okay, maybe in a bit of unconventional way, but at least based on current needs that we identify in the society. So
Yeah,
one way or
exactly.
another, yeah, stay tuned. Lastly, number 5, is there something we haven't covered that you want to say before we close out?
I would like to add that my mornings with coffee also starts with cold showers.
Ouch, I
Yeah,
would never do that.
but trust me, that is something that when I started that, let's say 7-8 years ago, I think it was 2015 when I actually started, it was, very hard. It was like just a few seconds. But then I actually realized that this is, for me, it was a great way that I adapt myself and I prepare myself for example, even the questions that I cannot be, let's say, ready, or that I'm happy to answer on those things because, lack of something of knowledge or something. But of course, okay, I will try. It's something that I will not, I will not say I can't. We will try, we will work, we will see.
Great. So it has been a pleasure having you here. Thank you so much for your time.
Thank you very much. I really enjoyed in this talk, in this coffee, and
And for our audience, if you can just keep one thing, just have your showers. At the temperature do you prefer, not necessarily cold ones. But I will still try the cold ones.
yeah, and tell me your experience.
Okay, until next time, bye.